Hello everyone, I'm Kushal from Indeed Inspiring, and we have been discussing conditional probability so far, and now we are going to discuss the Bayes theorem. Bayes theorem is a way of finding a probability when we know certain other probabilities. Okay, so conditional probability, you have seen that it is finding probability of an event given some other event has already taken place. We had discussed example of you have to go outside. So what is the probability that you will go outside? And what is the probability it is raining? So given that it is raining, what is the probability that you will go outside? This is a concept of conditional probability. And from conditional probability only, Bayes theorem gets derived. Okay, so once again, let's repeat. Bayes theorem is a way of finding a probability when we know certain other probabilities. Okay, the formula is probability of A such that B has already occurred can be found if we have probability of B such that A has already occurred, multiply probability of A and divide by probability of B. We can also interpret the same thing as how often A happens given that B happens. Okay, so this is written as P A by B. Okay, and similar way, probability, how often B happens given that A happens, and this is written as P B by A, and the rest of the two expressions are well known, probability of A and probability of B. Now, the important thing is how this particular formula or relationship has came into existence. So let us understand that part. So in this slide, you can see this is the derivation from the conditional probability. So you can see that the equation 1 and equation 2, okay. So equation 1 and equation 2 both are coming from are nothing but conditional probability, right? So they are the equation of conditional probability. All right. Now, from equation 1, we can derive the equation 1.a. So what we are doing, we are bringing probability of A intersection B here, and we are taking probability of A from the denominator to the right hand side. So this is the A.1 equation we have got. Similar way, from equation 2, we are taking probability of A intersection B, and the denominator we have taken to the right hand side. So we have got this expression. Now, because we know that probability of A intersection B and probability of B intersection A are same, so we can equate the equation 1.A and 2.B. Okay, so both the equations can be equated. So once we equate the both sides, okay, what we get probability of A given B into probability of B is equal to probability of B given A into probability of A. So this is the equation we get after that. And now it is very clear, you must have understood what will happen. We just need to take this probability of B from the left hand side to the right hand side. That is something we have to do. So here in this slide you can see that from the equation 3, we have just taken probability of B towards the right hand side, and we have got the Bayes theorem. Okay, so this theorem is known as Bayes theorem. All right, so I believe this is clear. Okay, so based upon this Bayes theorem, in machine learning, we have a classifier which is known as naive Bayes classifier. So in the upcoming video, we will also see the naive Bayes classifier. So thank you once again. Keep watching our videos.